Okay, looks like we are good. Let me just adjust this one. Oh shit. Okay, we are good in my phone. Let me just... Okay, nope, sorry. Okay. We are good. Sync. Yeah, we should be fine. So we have sound. Yes, we have sound. We have shot. Shot test. Yes, we have shot. So, welcome everyone. First of all, Happy New Year. I wish you all a very good 2025, full of happiness, peace, and projects, of course. I hope you guys had a wonderful New Year party. I know I had. Hey Kegel, how are you, my friend? So, again, Happy New Year to everyone. So I hope everyone is doing well. Why is this thing? Anyway, so yeah, I'm smelling burn. I hope it's not me, since I have my active eating vest, which is awesome. It uses a power bank. It has several heaters on the body. It's perfect. So we are back to the Milo CAD series. Milo v1.5 CNC machine. The CAD series, it's the modifications I'm making. So today we are focusing on the wakeovers. So one thing I hate on the original machine, and I guess they gonna address this because they are launching two new machines. I think it's kinda dumb, but it is what it is. So they are addressing some of these issues. They are launching with a version with ball screws, but they are using 8mm ball screws, and I don't know why. But it is what it is. So we are going with 12mm ones. And they have some kind of 3D printed covers, which, yeah, it's better than nothing, to be honest. But yeah, we'll see. So what else? So first of all, I have some goodies. So I received today, I opened one, not this one as well. So first I received the new pulley. Why is this thingy? Anyway, doesn't really matter. So I received the set for the Milo. So it's the pulley and a belt. It's a generic belt, but it should be fine. I'm gonna order a few. Hey Jose! Happy New Year to you as well. So it's the set for a 10mm belt instead of a 6mm belt, because it makes sense. It's a CNC machine. It's not a 3D printer, so I think it makes sense, especially when they are using a torque increaser setup, so it's a ratio 2:1 or 1:2 actually. No, actually it's 2:1 because it needs 2 rotations on the origin to give 1 rotation on the destination. And so yeah, I ordered, hey Joseph, I ordered these because I don't think it makes sense to use a 6mm belt setup. So it arrived, I believe it arrived, yes, it arrived today. It's cheap, it's an inexpensive mod. So what else? I received new motors. Or actually this is the driver. Oh, the sign was there on last stream already. I actually was seeing when someone would notice it, but I ordered that thingy from AliExpress. It's a LED matrix which you can control on your phone. Oh, fuck off. I can't now. So this one is very nice. I really like this one. Oh. It's awesome. Oh, okay. It has several setups. You can set text, you can do whatever. Super fun, a lot of stuff. So that's the brand. Oh, it's not connected? Give me a second. Okay, now it is. It's connected to my phone. There we go. Super fun. There's a lot of pre-done stuff. You can do a lot. So this is we put a little farther away. So this is the driver. As you can see, it's comparable with so this is a TMC 2209. So yeah, it's pretty much the same thing, as you guys can see. And yeah, this is something that I'm against on Milo. Why are not they using this kind of stuff? But even a DQ 556, I believe, or a 542, which is something like this. These are the proper type of drivers you want on a CNC machine. That's the whole point. So we have these guys, so the drivers. So these are HBS 57H. I can show it on other. No, the Milo factory uses the 2209s. The new versions which come with the silo, the silo, the new BTT motherboard. I believe they are 2260s, 2160s, something like that. It's not a 5160. I think it's 2260. It's kind of like the 5160, but they are high voltage. It's not the 5160. I'm pretty sure it's the 2260, something 2160. Let's take a look. Let's take a look. I need to open Brave, which I haven't opened yet. Brave. Yeah. Okay, so this is the air compressor that I was talking about. Okay, let's look for BTT Skylon. Okay, so the BTT Skylon comes with so it's the big processor, which is good. So it's the 2160s, which have 4.7 amps peak current. So these ones have okay, they don't actually say. So these ones actually come with not to select according the motor value or the motor model instead of the amps, but we can check. So HBS 57H, HBS 57H. Let's see if we have the features. High speed. What do you mean? What do you mean? What means as much current as you want? So the 20 to 2160s, right? So the 2160s are 4.7 amps peak. Peak. It's a very important word here. While the okay, the HBs, it's 6 amps peak. It's not that, it doesn't look that much, but it's quite a lot much more. Ah, okay. Yeah, on mine it doesn't say, because it does say, usually it has a setting with deep switches, where you choose from 2 or 3 switches the amps you want, but on this one instead it says the motor model. So if you have the 42 millimeter model, or the 57, or the 70, or the 60, or the 86, I have the 86, we set the deep switches according to that, and it's not actually the value of the current. But my motors, I know they are rated for 4.2 amps, so it's not a peak value, it's the rated value. What else? Main? No, not main, sorry, front. Yeah, exactly, that's its point. Okay, so these are the drivers. I have 3 of them, one for each axis. I'm not worrying with, for now at least, with the 4th and fifth axis. We'll see later when we do that. So here we have a motor. No, I can't. So this is one of the motors I'm going to use. They look very big. Well, they are quite big, but so this is actually a 14. So let me grab. Do I have a NEMA 17 somewhere? Not sure I do. Well, I do have one from the extruder. I think. Or maybe I don't. Where is it? Not here. Oh, it's here. Okay, so I have one of these pancakes, which we can compare the size difference. I know it's unfair, but and let me grab one from actual Milo. So this one, it's from Milo. And this one, it's for the one I'm using. The shaft is bigger. So here, actually, this is not a motor from here to the back. The motor, it's only from here. Even so, it's quite a big chunk more. This is actually the encoder on the back. So this is a 56. This is a 76, I believe. Yes, this is a 76 millimeter motor. It says there on the tag. So yeah, this is much beefier. Actually, one thing I don't like, it's the encoder connector. I'm pretty sure I'm gonna just solder the. It's very big. It only needs 6 connections and it has like 15. So I'm not sure about that. I need to find either some smaller connector, or I'll just rip off the connector and solder the wires directly. It's probably what will happen. It's nice to have a connector because if you need to change the motor, you can just disconnect it and change it. It's usually the motors don't die, but the encoder can die. Even that, I never had one dying on me. So yeah, I have the 3 motors as well. Can show here on the top camera. So we have the drivers and the 3 motors. So what else? Let me put this aside. So I got these two guys. So these two are for the Micron. So since they are here, probably I'm gonna change them. So the thing with these, it's the long shaft. It has the long shaft, so we can support the top with an extra bearing. So these are for the these are the A and B motors. So we can support the top with the bearing. I think they call this the dual shear mod, something like that. So this was a group buy on the Micron Discord, or the Printers for Ants Discord, for a custom made long shaft version of the motor from Steppers Online. So probably we're gonna mount this on the Micron. What else? So I bought this mini PC for the Milo. I'm not sure whatever I'm gonna use yet, but I like to have the options, and I need one of these anyway. So I decided to buy it. So this is so these have 8 gigs of RAM, 256 gigs of SSD, and it has a quad core, I believe 2.4 gigahertz. It's Intel 12 Gen. It should be way more than enough for the Linux CNC. It has one thing, it's small, and it can be smaller if we do that. This thing, it's only for adding an extra hard drive if we want. So you can put another 2.5 inch SSD in here. But if you don't need it, you can have these even smaller. So this should be more than enough if we are using the Mesa card, which I have no idea if I'm gonna use yet or not. We'll see. Probably yes. So it just needs a 12 volt power brick. I shouldn't have, to be honest, thinking now, I should have bought I got this one on Amazon. I can show whatever. Let me get back here. So I got this one on, it cost something like 140 euros or something like that. It's not cheap, but it's not cheap, but it's quite cheap. Who makes it? Someone in China. So I just searched for mini PC, and yeah, it's pretty much this one. So it's an Elder Lake N95. There are millions looking like this one. Some are cheaper. To be honest, if it was now, I wouldn't buy this one. I would buy either one of one of these, which, oh no, sorry, it's not this one. It's like this one that has a dual Ethernet port, since we're gonna use one for Milo, and I would like the other one to have access to my network, but something like that. But to be honest, what I still can return this one, but what I should have bought, it would be something like this. This would be ideal. So I'm just on AliExpress. I'm gonna look for J 1900. So these little guys would be something like this would be the ideal choice, or something like this. So this thingy has HDMI, it has the dual LAN, you have one DDR3 slot, which is more than enough, and more importantly, you have a parallel port header. So that means with this thingy you can use Linux CNC without even buying a Mesa card. You can use the parallel port. Or when I say this one, even this one, it's also cool, but this one is mini ITX, so you need a power supply for it, I think. Well, maybe not, because I see the plug there. Yeah, there's a plug there. So you have a DDR3 slot, and this thing, it's more than enough, and it has a parallel port header as well. I'm sure I've seen it before. Let me go here to the description. So it's a quad core, 2 gigahertz. Oh, actually 2 times DDR3. And you even have a PCI Express. And I'm pretty sure, I'm not absolutely sure, but... Okay, let me see. So you have the PCI, USB 3. Oh, maybe I'm wrong. TPMS 1. Not sure if that's the parallel port. SATA. Okay, let me look at another one. So I know there are some of these with this processor, with the J 1900, that have the parallel port header. Can even be on the other side, to be honest. Yeah, but one of these NUCs should be fine. Some of these have wireless already, but these are on the box and it's not ideal. Let me see if there's one with a... No. Oh, at least here we have a description of the I/O. Let's see here, description. Okay. So internal I/O, we have line out, COM, 12 volt, an LVDS. So that's for the screen, RS3232. So actually this one doesn't have a parallel port. MSATA slot. Well, the point is getting something like this, but with a parallel port. I have one, but it's too old, I believe. I'm not sure if it will be able to handle. It's downstairs. I bought it like 7 years ago, and yeah, I think it's too old. Anyway, I think the ideal solution is to get just a Mesa board and get over with it, and don't think twice. Since parallel ports are so in the past, it's just, and if it dies, it's a pain to replace anyway. And Ethernet, yeah, PCs don't have those anymore. Yeah, that's right. So Ethernet, it's gonna be here for a while still, and I think it's the way to go. It's just I want the idea. I haven't ordered the Mesa board yet, but when I'm gonna do to it, it's gonna be a 7i 96S, and yes, we can buy it. You can buy it online here on Europe, on this website. I think it's the cheaper I could find. That's plus VAT. And this thing, it's a beast. This thing can cover 5 axes easy with a lot of I/O, and you still have a parallel port header where you can just connect another breakout board, parallel port breakout board, and use a lot of another like a bunch of I/O more. And this is not like parallel port transfer data rate or data transfer rate. It's much quicker, because this thing, it's the processor that's messing with it. So it's just like you can use a parallel port breakout board, but it's not like an actual parallel port. It's just more I/O. Yeah, the advantage of the Mesa card, it's everything. First, the Mesa card, it has self-processing steps, so it doesn't rely on the operating system CPU generating the steps for the parallel port. The parallel port data transfer rate, it's messy and it's very low. It's old protocols. So the Mesa board just receives the information from the CPU and processes the pulses itself. It has a much higher transfer rate. It's much less lag, because it communicates with a 100 megabit Ethernet connection. So yeah, it's just it's just much better. The idea here would be to keep the cost lower. So if you want to at first start with Linux CNC, and you don't want to spend, okay, I already need to buy a PC, then I need to buy a Mesa card, it's going to get expensive. And if you get a cheap PC, like all-in-one of those boards like I show you, with a parallel port, you can start, at least you can start with the parallel port and then upgrade to Mesa if you want. To be honest, I ran my CNC router, a big one, with parallel port for years, until the PC actually died and I was in a pain to actually get another computer with a parallel port. That worked with the Mac 3 drivers, and I just decided to go at the time for Mach 3. There wasn't as many information with it wasn't very information. Sorry, I'm having a spin out. There wasn't as many information about Linux CNC as it is now. So, and I was used with Mach 3 already, so I just bought Ethernet Smooth Stepper, which is a Ethernet board for Mach 3. Basically, it's an Ethernet. It's a board that connects via Ethernet and gives you 3 parallel ports headers. Again, like this one. So it's not like actual parallel ports, but you can connect 3 breakout boards from on. So one breakout port on each of the headers and get all the I/O from a parallel port. Much faster, much cleaner, much less noisier signals, so it's much cleaner signals. Everything it's better, to be honest. But again, the price is the same, and you can buy. If you look, there are these NUCs are super. You can get like an NUC with a parallel port for like $50, and it will work. It is what it is. It will work. N100. I think the N100 mini PC. Okay, no. I looked so many. Okay, let me see. LPT. It's LPT, right? The OLTP. I think it's LPT. LPT Nuke. And then there are these PCI to parallel port converters, but to be honest, not all of them work. That's the big issue. Downstairs I have a so this is a Core i5 Series 3. What's this? Okay, so this is a J. I know there are some. Okay, let me look for J. Yeah, it's LPT. Okay, so. Okay, I could swear I saw some cheaper. But yeah, if you buy one of these things, you don't need. Damn it, but that's quite expensive already. You don't need the Mesa board already. Or if you have some old PC with a parallel port around, not all of them work. That's important to know as well. Because you need a low lag on Linux CNC. You have like something like a benchmark that will let you know how much lag do you have, and according to that value you know if you can run the thingy or not. There are also yeah, I have quite a few as well now. So there are also another option, which is a Raspberry Pi with a parallel port hat. I know there's someone that made one. We can take a look. Raspberry Pi. Yeah, I think it's this guy. Okay, so there's this guy, which is not that expensive, 35 euros, and you can connect this thing. You can connect this thing to the Raspberry Pi and install Linux CNC in Raspberry Pi. And actually Raspberry Pi 5 has a lot, the lag value is very, very low. So it supposedly worked very well. And you can get the party done with like 100 euros because it's about 60 euros for the Raspberry Pi, 35 for the head, and like 10 for the breakout board. And you'll be good to go. Supposedly, that's another option. And forget these adapters, these USB to DB25 adapters. You can work with them, but only for I/O, regular I/O. If you need like a panel or something like that, not for controlling access. It's a no good. So yeah, you have that option as well, and I'm not sure. I don't think I'm gonna go with this one, to be honest. I have I think I have, it's an ASRock AD25 22. Let me see. No, it's not. Oh, it's probably this one. Yes, I think it's this one. Yeah, I see. Yes, it's probably, if it's not this one, it's very, very close to this one. I have one of these thingies downstairs, brand new, never used. Yes, I think if you're buying new hardware, two options. Either go with one which can handle Mesa later, if you don't want to spend the money on a Mesa board right now. So I think that's but yes, again, everything you can buy using a parallel port will have an Ethernet port, and you can always upgrade it to Mesa later. But if you don't want to spend the Mesa right now, you can always get something with a parallel port and just get started with it, and then move to the Mesa if you want to, if you feel the need, because sometimes there's just no need. And you can get just a parallel port breakout board and connect everything, and if it's working, it's working. You don't need to fix anything that's working. So I think the Mesa, it's a more long-term solution. It's better overall. It's going to be cleaner, and it's going to be just better. Maybe the machine, probably the steppers won't do as much noise because the signal is cleaner, that kind of stuff. But it's a Gucci thing. It's expensive. So yeah. So again, I have one of these, and these things have these ones I'm absolutely sure that there's a parallel port header, which is there. That whitey thingy, it's a parallel port header. So I'm absolutely sure that this thing can work. I'm just not sure if the processor can handle with the parallel information and loading the Linux CNC and whatsoever. It's a dual core Atom processor, which is, well, weak to say the least. it can get 4 gigs of DDR3 RAM. So I have one of these, so we can always try. And I also have breakout boards from my machines that I replaced. So I have absolutely no extra. I don't need to buy anything else. I just need a power supply for this thingy. That's the only thing pretty much I need to buy, and I'm gonna buy because I want to try that solution as well. So I have one of these thingies. I have a mini PC. I have a Raspberry Pi, but I don't have the Pi at, the parallel port at. So there's no bueno. Anyway, I can test Linux CNC pretty much on every taste and shape we want. So just to have some information at least, and this thing cost me like 60 euros 7 years ago, so probably we can't even get it new anymore. Let's see on AliExpress if there's something like that. Oops, that doesn't work too well. Nope. But I'm pretty sure we can find something closer to it. Anyway, what more? So yeah, I showed the mini PC, and what else? One other thing I bought. Let me put the top camera. And which arrived already as well is this thing, which is a 16-inch touchscreen, which I want to use to the controller. So I want to make a panel, like a CNC panel, like an industrial machine with buttons and whatever. And this is going to be the screen for the system. So it's a 16-inch, 15-point touchscreen. It's USB-C power. It's very thin. I bought this from AliExpress, as usual. It works, I tested it. It works on Windows. I haven't tested it on Linux, but people say it works. So I assume it's gonna work just fine. Yeah. So this thing costs like 80 bucks or 90 bucks on AliExpress. I wanted something big because I like to have the axis, the arrow with big numbers and letters, and touch. It's kind of a must nowadays. So yeah, it's pretty much 16-inch portable touchscreen. Yeah, it's this thingy. 88 bucks now. I bought it for, I think it was 92 when I bought it. Yeah, because it's a little cheaper now with the winter sale and whatever. Yeah, but it's this thingy. It has a beautiful image. It works just fine. The touchscreen works great. So yeah, it's just this thingy. 60 Hz, whatever. It has dual SBC, so you can connect power from one, then you need the other one to actually get the touch. Connects on mini HDMI, And yeah, that's it. You can power it with a USB-C, as I said, so it's just fine. And yeah, so let's go to work, since we talked for almost an hour already and done nothing. Okay, so we have the Fusion here. I have the model opened already. Okay, so the idea is just to figure out the wakeovers. Okay, one thing, I modified the, so I had another, I'm not sure which is the best yet, so I designed the second version for the ohming of Y. And why have I done that? Because it's gonna be all about the way covers. I think this one is too bulky to a couple of things. So first, I think this one is cheaper. This is gonna be cheaper because this is a little piece of aluminum compared with that one. It's easier to machine, much easier to machine, to be honest, and only requires the a slight modification on the on this guy, on the, so just 3 screws, 3 holes with 3 threads. So I think it's better, and it's just like this. It's self-explanatory kinda. So it's just like the sensor screws in here, business as usual, and the sensor and the plate screws in here, and it has slots where we can adjust the position, just sliding. And when the x-axis come back here, it just triggers the sensor. We can adjust the trigger position as we want. And yeah, that's pretty much it. And it's slimmer. I think it's a better solution. So I think we're gonna go with this one instead. A few things that so when will I start the build? So now I need to finish a way to cover these the linear rails and the ball screws. So hopefully we're gonna finish this today. I need to perfect the aluminum parts, but that's just, it's gonna be, it's fast. Even if I don't do it on stream, it's I can do it out of stream. So I really hope today it's the last stream of this series. Then I want to, what the hell? Go away. And then I need to finish the Micron. I really want to finish that project. So then we're gonna finish the Micron, and hopefully we're gonna finish the way covers today, so I can order them. Yeah, bellows, way covers, you got whatever. As soon as I finish the Micron, we're gonna start on this one because I only need to order actually the wake covers, and I need to order the aluminum to machine the parts that we need to make. So I'm assuming sometime like the end of the month, we're gonna start with this thingy. It would be nice. What the hell is this doing here? Why is the X motor mount? I think I moved this thing in here by mistake. No, probably I did something like this, probably, I'm not sure. Probably something like this, you know? It happens sometimes. Yeah, it's exactly what it was, so yeah, I'm pretty sure I fucked up something like that by mistake. Okay, so yeah, as I said, we should finish the micron by the end of the month and start with this. I'm gonna polish the aluminum parts, make it more beautiful, more aesthetically presentable. And yeah, and then we're gonna start with it. It's not a big deal, it's just a few pieces of aluminum I need to buy. I ordered already the ball screws, the custom ball screws for this thingy. I ordered 2 sets actually from 2 different sellers because I want to see which ones are better quality. The price is exactly the same. It was like $3 difference for the same thing. So the price, it was pretty much the same. It's about 220 euros the set, the full set for these, and this is for ball screws with dual nuts, so it has 2 nuts on each ball screw, which it makes it like at least 10 euros more on each, because each nut costs about 10 euros, 10, 12 euros, something like that. With the bearing blocks with angular contact bearings, not regular radial bearings, which is also about 25 euros to 30 euros per set. So yeah, I don't think it's expensive at all. I remember when I did my first CNC machine, one of the ball screws cost about the total of these, so it's nice. So I was saying, one thing I noticed, I don't quite understand. I don't quite understand the design here. So as you can see, if I go here, so we can't move more because it's physically impossible. The table just sorry, let me just unpause the music on YouTube. Okay, so the table is just physically touching the column, so there's no more travel. And yes, okay, the spindle, what matters, it's the spindle center. It's out of the table, which is perfectly fine, right? Now my main issue is if you push everything, so if we home Y, so we get here to home Y, as you can see, the spindle is too fucking far away from the the table, right? So in order, I may change this, but in order to get more space for the way cover on the back, I think I'm going to increase the this distance here, and probably I'm going to do it with spacers instead of machining the aluminum part bigger. I can always do it bigger and then cut it down, but I think it's better if I do it bigger, or if I do it small and just add some spacers in between the plate and the brackets itself, or the clamps, or whatever. So yeah, I think I'm gonna do that. Because otherwise I need to buy a big chunk piece of aluminum, and then if I regret my decision and I need to move the spindle, ideally you want the spindle closer to the column as possible, but in here I don't see, I can see, but first we need to design the bellows, or the wake overs, whatever you want to call it. So the idea is to design the wake overs, and soon when we design the wake overs, yeah, for a massive spindle on a small machine, that brings me memories. No, you have bigger ones. But I made the design according to their design for the 80mm ones. But yeah, I can show you. Sorry. So at one time, actually at much time, I had this thingy. Where is it? Let me see if I can find it. Well, actually it's... yeah, this is probably the same as the... I think this thingy is the same as the... It's not the same because this one it's 2000 watt, 2200. Yeah, it's 80 as well. So I use this thingy on my 3040 CNC. This thing, it's fucking heavy, it's water cooled, and this thing alone, the weight of it would bend my Z-axis. I have to beef everything up. But it worked for like at least 2 years with this thingy. But yeah, I see your point. Like people is using now a square spindle, which is in my opinion a better option, but I don't see, these will work just fine, to be honest. The main concern I have about this spindle, the spindle that comes with the machine, is being 24,000 RPM. If it was 18,000, it would be way better. On my router, I have 3.5 kilowatt, I believe. I think it's a 3.5 kilowatt spindle. It's a square one, but is 18,000 RPM. which is much better. You can use it at 10K, hogging aluminum. It will not complain at all. But yeah, we're gonna make it work. Ideally, or later on, I intend to make a custom spindle with a servo motor. It's gonna be fun, to be honest. But yeah, that's gonna be later on. The idea is to get something like a 2 kilowatt servo and spindle. I'm not sure. I seen some interesting stuff on AliExpress, to be honest. Actually, something like a BT. I would love an ISO 20, so to make a tool changer. That would be a fun thing, to make a tool changer on this machine. Not an automatic one, because I don't see the space for it, but at least a manual tool changer, but a fast tool change would be nice. And I seen some stuff that's not very expensive, to be honest, and it should be fun for this machine, but we'll see. So anyway, I was saying, I think I'm gonna push the spindle a little more to the front. And why that? To gain space on the back, because the main problem for the wakeovers, it's gonna be, we can start with this one, and you guys are gonna see it's gonna be just fine and simple to make. Because right now what I need to design, it's pretty much just the shape. Oh yeah, servos will give you much more torque, because you're gonna have a max. If you're gonna do a direct ratio, a servo, I mean a normal servo, not a spindle servo. A servo will give you, like, I don't know, maybe 4,000 RPMs maximum. And you're gonna have like if we're gonna use like a 2 kilowatt servo, it's gonna be a 2 kilowatt at that speed, so at 4,000 RPM. For cutting aluminum, you don't want high RPMs. You want at maximum like 8K, 10K. It's I usually on my big machine cut aluminum at 10K, and it's going to be at high speed cutting. And this machine you can't get high speed cutting on this machine, because I cut aluminum faster on my big machine than this machine will move on rapids. So you don't want too much speed. If you get like 4,000 to 6,000 RPMs on this machine, it would be ideal, and you will have a ton of torque. It's going to be fun, because it would allow you to do tapping, like rigid tapping, open threads with a tap, which is awesome, to be honest. You can still do it on this machine, but with a treadmill. So basically you're going to interpolate a thread on a hole, but with tapping you just like screwing in a tap and screwing out. It's awesome, because if you have a servo, you have you know the exact rotation, because you have a feedback. You have an encoder giving feedback to the system, telling the speed, that the exact speed that you are rotating, and then the system can adjust on the fly the speed of the Z to match the pitch of the thread you're using. It's pretty cool. If you have enough torque and enough, I'm not sure. I'm kind of speaking out of my ass here, but I'm pretty sure it can be done. So you can control, if you have a servo, Let me change to the frontal camera. So if you have a servo, you have several ways to control a servo. A servo, it's not like a stepper. A stepper, you give steps and it rotates. A servo, it's different. Well, it's kind of the same, but the driver, it's a lot different. You can control a servo. So the servo is connected to the driver, and you're gonna communicate with the you can communicate with the driver and tell it and control the servo in several ways. Like, so not all servos, but most of them you can control by torque. So you define torque to the servo work, and the servo will work at that torque. You can control it by speed. So you say, hey, servo, rotate at that speed and that speed only, and the servo will rotate at that speed constantly. Or you can control it by like a stepper with pulses and direction and step pulses. So usually on a spindle you control it by velocity. So you tell, hey, spindle, rotate at 10k RPM, and the driver will will have the motor rotating at that speed. But you can also rotate. It will oscillate a little bit, like 1 or 2 RPMs, depending of the speed you're setting. But for instance, many machines have rigid tap. Rigid tap. What it means? So usually when you do, or early on when you do tap on CNC machines, you would use a buffer tool. So what that means, it's a spring tool. So if you have a misalignment or a mismatch of the RPM and the speed of the Z, the tool itself has a spring system that will allow the error. So if you're rotating a little faster than you should, so that means you're threading in a little faster, it means your tool will be pushing down faster than it actually should. And if you're rotating a little slower, then it will do the other way. So it has like a double spring. It has a play that allows the tap to move back and forward or up and down, compensating any mistakes and any slight. We are talking about very slight mistakes. But many controllers, and I'm pretty sure Linux CNC does the same, you can switch the mode that you control the servo. I know my controller does that on my big machine. So if I do a thread operation, what it does, it changes the mode that I'm controlling the spindle servo from velocity to step and direction. So it will behave. So now the spindle will behave like a stepper motor. And that way it will be much more precise than you have the spindle rotating at some speed and the machine are reading the speed from the spindle encoder. And when so let's say the spindle is rotating exactly at a 500 RPM, but when you touch the material, you're gonna get load, and it's gonna drop from 500 to 498, and then the system needs to be reading the encoder speed and then adjust. Okay, so now the Z that was moving at 100, it has to move at 99.6 millimeters per second or millimeters per minute, whatever. So you see, when the machine, the controller needs to be reading the spindle rotation on the fly and adjusting the Z movement on the fly according to that. So if you if you change the spindle mode to an axis mode, so you're gonna control it like a regular stepper motor, like an extra axis, it's much more, because the driver, it's much more responsive, it's much more precise. You can basically use what we call rigid tapping. Rigid tapping, it means you eliminate that buffer stuff. You just chuck a tap on the spindle and it will force it down with no play, no nothing. It will forcing down the material at those speeds because it's much more reliable. Because the controlling system, it's much more precise. Now you can have rigid tapping or use a machine. Rigid tapping is just a fancy name for very precise. It's just like when you advertise rigid tapping on your machine, it just means, yeah, my machine is just precise enough that I can thread in a screw on a hole, on a threaded hole. It's pretty much that. So it just means it has precise tapping operations. And with the servo you can do that. So if we use a servo, I'm pretty sure Linux CNC, because you have communication from and usually on the driver, the servo drivers, you have some lines of input where you can, usually we set the stop or the emergency stop operation, which when you get a signal on that pin, on that input, the driver will stop the motor as fast as it can. It's usually what we use for the spindle stop, so the M9, no, not M9. I don't remember the M code, but the M code to stop the spindle. I think M9 it's for the cooling. I'm not sure. Doesn't matter. Or M0. It's M0. M1 it's for clockwise rotation. M2 is for counterclockwise. So usually we have that for the M0 command. So when we want to stop the spindle, it's every time we want to stop the spindle, it's an emergency stop. It's not like if you let the spindle coast until it stops, it's gonna take a long time until it stops. So there's that. And then you can use like other inputs. You can use an input to reset in case of an error. Okay, you set that pin where you press a button and you reset the driver if in case of an error like over current, over temperature, whatever. If the spindle gives you an error and stops, you can set one of those to just reset the system. And you can have one to switch the mode. And you can say, oh, the input 3, it's to when it's 1, it's gonna switch the servo mode to step and direction axis instead of speed mode. The default is speed mode. So you can just and when you use a tapping cycle, the controller will automatically set the machine to do the tapping, which is going to change the mode of the driver, and yeah, and that's pretty much it. So yeah, I've been rambling away. Yeah, I hope now you know the difference. At least you learn that. Yeah, rigid tapping is fun. My machine has it, and I must say that thing, it's a wonder to see. And especially on my machine, the tapping cycle, every time I do a tap, I orient the spindle so all the threads start at the same place. If I need to redo the thread, I know I can go back there, because the machine will start the tap always on the same position, and I can redo the thread without cross threading. It's super fun. rigid tapping is fun. It's something I can say, that thing it's fucking awesome. And I've seen some demos like of machines just screwing screws on threads and unscrewing them. It's no, 4-axis. It depends what you get from 4-axis. For me, for 4-axis, it's not like a lathe. Many people think 4-axis on a mill it's like a lathe. It's not. So it's basically one, you can index work. So you need, let's say you have a screw, an X, and you want to do, let's say we have a cylinder and you want to do 6 faces on the thing. So turn it into a X. So the spindle will index, so it starts at 0, you face it, rotates 60 flat, and you cut it, rotates another 60, you cut it, and whatsoever. That's one. That's indexing working, and then there's interpolation. Like, let's say you are machining something like a cam drive for a crankshaft, you guys call it, for the thing, the eccentric from the engines to open the valves and whatsoever. So it has those wobble thingies. So when the wobble comes, you need to push the wheel up. What the thing is rotating slowly when you cut, and basically you are interpolating. You're moving X, Z on top, up and down, according to the rotation of the A-axis. So you don't really want it to be like spinning. Of course, there's an idea for that, but it's really difficult to. That's a no other level of control. That's a mill turn. What you meaning? I understand what you want, what you would like, and that it's a mill turn control. So it can either index or whatever, or it just can spin it like a lathe, and you move it with a cutter and cut it like a lathe. So that's a different thing. Yeah, I think it's a crankshaft, right? I think it is. Doesn't really matter. Okay, let's go. Let's go to work. Well, at least now you guys know the difference between rigid, a camshaft. That's it. Camshaft. That's it. You're right. Camshaft. Okay, so in here I'm just gonna. So I'm really set on these 45 degrees here. So these will be epoxy in here, and I'm set on these just because I learned my lessons. So what I'm gonna do, I'm gonna actually design it in here. Let me give some color to this guy. So that's the X plate, no, the saddle plate. So let me give it 50%, no more. Let's give it the 100% opacity for now, at least. Okay, so why do I want these ramps here? I want these ramps because when the ships come drop on them, they just roll over to the floor. And yeah, that's pretty much it. So what I'm gonna do, I'm gonna do a sketch in here. I'm gonna capture position, doesn't really matter. So basically, what do we want? We just want the shape. So first I'm gonna project this guy and this guy to our design plane. And we want some clearance, so let's go from here. So this is going to be the inside of the bellow. Okay, this doesn't need to be very accurate for now, at least. So I'm gonna put just like that, just to make sure they are equal. Okay, let's say we want something like 7 millimeters from here. And I'm gonna project this line in here. So we know that's the top of the sensor. Let's keep it something like 2 millimeters from there. We want the bellow to be as wide or the large as possible, because the bigger the bellow will dictate the full length. The bigger the bellow, so it means the fold is bigger. So if we have like this, when we stretch it, it will go only to that, right? But if we have like this, when we stretch it, we go much further. And so the deeper is the bellow, it means the retracted length will be the smaller. I hope I made myself clear on that one. So then we can do this. Again, I'm gonna make these two horizontal so it stays symmetric. So the idea here is to be as how can I, yeah, I'm gonna project this face in our plane. Nah, that wasn't a good idea. Okay, let's do it just by high. Okay, so how much do I have like that? So we have 25. Hey XI! Red me! Okay, so if we have 25 there, we want 25 here. And that one will be self-imposed. And we can do, instead of pointy bellow, yeah, 75 should be fine. So these can be the shape of our wakeover. X, oh, not X, sorry. I want it to be collinear with this one. This way, if I change this value here, it will change that one as well. 75 looks good. So we have here 144, so I'm just putting that's driven because we set 7 there. If we put 7.5, we're gonna get it to 145, which is a nicer value. So yeah, then we need to figure out, actually we should use the whole, doesn't really matter. Then we design some 3D printed covers. We're gonna need to hold the bellows anyway, so doesn't really, hey Luis, so it doesn't really matter. So in theory, since we have a 25 millimeter bellow, it means full stretched, it should be, in ideal conditions, it should be 50 millimeters, right? Because it's gonna be fully folded and fully open. In real world, it doesn't work like that. It's gonna be something like 45 or something. I need to ask the Happy New Year wish as well. I need to ask the seller about the with the 25 millimeter how much. So when we are, we have basically the basic design of the thingy. So what we need to do now is to let know the seller, hey, we need to cover, and we need to cover from here to here. So we need to cover roughly 250 millimeters. We need to tell the seller, hey man, we need a bellow or a way cover with this design, like this. We can do some tweaking in a minute. With this design, like this, like that. And we need to cover 250 millimeters. So this thing has 25 millimeters in here. How much would we need to get a bellow that covers 250 millimeters? And they will tell you, okay, for 250 millimeters you're gonna need at least let's say it's no, it's not, it's less, like it's 5 millimeters per bellow. So, and each bellow extends 45 millimeters, so we're gonna need something like 250 millimeters divided by 45, which is the maximum extension. So you're gonna need 6 bellows, and each bellow is 7 millimeters, so times 7, so you need 42 millimeters. So it means that I'm just pulling out numbers. I'm not sure if it's gonna be something like this, but I'm not sure exactly how much, but it's gonna be something on this area. You're gonna need 42 millimeters fully, the bellow fully retracted. And then you have the top cover, the front cover, and the bottom cover, which is some harder. It's harder material, to like PVC or something like that. I'm not sure which material it is, but it's something harder where you can fix it. So you can fix it actually to the machine. It's going to be like 4 millimeters. So you have 8 more millimeters. So it's going to be around 50 millimeters for that design of cover. So we have here 36. So it may be less, I have no idea. I'm just, like I said, I'm just pulling out numbers. I'm gonna need to ask with this shape, what can we work with. So, but anyway, we're gonna need that number again to here. So this one, it's going to be smaller. So it's, as you guys can see, it's 230 millimeters. Slightly smaller. But we're going to have much less space. So if we go it like that, we only have like, I don't know, 20 millimeters, something like that. Not even that, we have like 18 millimeters. So we're gonna need to win space. We're gonna need to get more space to install the way covers. And the only way we can get more space, because let's say we need 50 millimeters. I don't think it's that much, but let's say we need 50 millimeters for the to install the thingies, the way covers. So let me put this thing roughly at 50. So from here to here. So yeah, we are at 49. That's pretty much it. So you guys can see now our spindle doesn't reach the back of the machine. So for how much? So let's say from here to here. So we are missing like 24 millimeters. So the way we can surround this or avoid this problem is to move the spindle 25 millimeters to the front, as I was saying earlier. From here we are So we are 44 millimeters out of the table. So it means if we move the spindle 24 millimeters to the front, it shouldn't be a problem. So let's try to do that just real quick to see the difference. So in here, I'm just gonna reshape this. I'm gonna increase this value here, plus 24. Okay, I need to put this one as well, plus 24. It's just to quickly show the difference. Okay, so now we have we still are way way back from the table. Actually, we're gonna need to move more. We don't need, but we want, because we want the spindle to pass the center out of the table. At least I like that. So what this means? This means when we go here, actually let me edit the joint limits. So we have the minimum, the maximum. Okay, well, so let's put here the minimum minus, no, the maximum. Yes, the minus, the maximum, like that. So if I put minus 50 there, it means that right now I should be at 50 millimeters. Okay, now I'm at 50, And this is okay, no, I messed up. I need 50, but from here. So we have 60, so less 18. That's what we need. So edit limits, I'm gonna do 32 in here. Okay. Which now I should be from here to there. Yeah, roughly 50 millimeters. And we have the center of the spindle pretty much on the edge of the machine. I don't like that. I like to have the full access. Let's say if we usually on this type of machine, on this spindle, we're gonna use something like at maximum, or most of the time, 6 millimeter mill. I think it's gonna be the most used mill. So let's say it's a 10. It's a 10 millimeter. So if it's a 10 millimeter, we're gonna need to at least move 5 millimeter more out of the table, so we can reach the edge of the mill. It's gonna be 5 millimeters out in order to get our desired position, right? So let's add 6 more or 5 more, doesn't really matter, to our value here. So let's say 30 for now. I need to figure out, we want the minimum possible. But first I need to know the size I need for the bellows to be the minimum. So when they are retracted, fully retracted, what's the full length of the thingy in order to work with this. Okay, so now I'm assuming 50. I'm pretty sure it's gonna be less. It's gonna be more on a 40. But then we can adjust again when we have some more information about the bellows or the wakeovers. We can adjust the design accordingly. Okay, so right now, as you can see, we have the center passed. We can do another thing actually. Where is the spindle? So we have the spindle here. See, I'm gonna do a 12 millimeter. 12 is the absolute maximum, and I don't even recommend because I couldn't find any collets. So this spindle is ER16 clamps. It uses ER16 clamps or collets or whatever, and the ER16, it's the official recommended maximum size is 10. It's 10 millimeters. I think it's 10 or 11. I'm pretty sure it's 10. But you can get some unofficial collets which are a little bigger. So the absolute maximum you can get it's 12 millimeters. I don't even think you can get half an inch. Half an inch is 12.7. So I think 12 millimeters it's the absolute maximum, but I couldn't find a 12 millimeter collet with an high accuracy. So there are very different accuracy or precision types of the collets, and basically the accuracy is the runout you get from them. And the runout, it's basically the concentricity. You want the lower runout, the better. So it means the tool runs closer to not wobbling as possible, like closer to perfect. So yeah, the only ones I could find with 12 millimeters are rated for 0.008 millimeter runout, so 8 microns runout. So what that means? That means they will wobble at maximum 8 microns, but you really want the lower value as possible. So I haven't went to like professional precision tool making brands, because these things get expensive really quick. I usually buy them from AliExpress, and I buy the best I can find. So usually the best you can find on AliExpress, it's 3 micrometers runout, which actually where I used to buy them, I usually sometimes I need to measure. Most of the time I don't need, but sometimes I need to measure and to make sure everything is fine and it's actually accurate, especially on really small mills or drills, doesn't matter, or reamers. If you want a perfect hole, you need to start looking at that stuff. We're gonna get to that when we start working with the machine. But yeah, so you want the smallest as possible, and again, as I said, this is ER16, and ER16, the official maximum tool diameter it allows, it's 10 millimeters. I'm gonna put 12 just because there's a possibility to use 12. It doesn't mean it's a good idea. So this is only for reference anyway. So what I'm gonna do is just put a 12 millimeter shaft here, like simulating a tool. But actually, let's do it. Let's make it 10 millimeter. It's just to simulate the tool, so we can actually see. Okay, now I'm gonna update. And as you see, we have, with a 10 millimeter tool, we have a gap from the table, so we have access to the very edge of the table there. And we have space here in the back to put our so we have the access here so we can mount the wakeovers. So one thing I would prefer these wakeovers, instead of being square, I would like them to have some kind of 45 degrees angles. So instead of being a square, being something like this, which we can do actually. So the fixed thing, it's the linear rail. So we can do that. I'm gonna make it 45 degrees. So 135 in here. And I can project this point. And let's say I want it, just to be sure, 3 millimeters out. I'm gonna do the same on this thingy. I'm gonna make it, thank you. I wanna make it like that, and I wanna make it the same angle as this one. And then we're gonna do the same in here. Why this? Because the more angles it has, the less plane surface it has, less ships gonna be stuck on it. So you want this this face in here to be the smaller as possible. So here we're gonna be 25 as well. Gonna be the same as that one. So yeah, basically that's the shape we want. So I mean this and this. So this is the shape. Oops. Like that. So this is the shape we want for the bellows. How are we gonna fix them? That's a later problem. We can figure that out. First, I need to check with the guys that make the wakeovers. The price, it's gonna be cheap. I'm pretty sure it's gonna be something like 20 bucks for each bellow. This is a small thing. Ideally we're gonna have them both the same size, because now if we're gonna see from here to here, it's smaller already. So it's I have the machine, yes, I have the machine on the best. So we have something like 215 millimeters. So let's say 215 divided by 45, which is the value we kinda guesstimate. So we're gonna need five bellows. So 5 bellows, let's say each bellow, it's gonna be something like 5 millimeters, but I'm gonna call it 7. So it means we need 35 millimeters for the guides, and we have the 4 millimeter front and back art plate. So that's plus 8. So we have 43 now. And we have here, how much do we have here? We have 36, so we only need 7 millimeters more. So that means if we start from the back of the plate here, which we can, or we can do just we can do a 3D printed part in here, which will attach. I can do some, that's something we can figure out later. A 3D printed part that will screw in like some holes that I can do in here on this part and fix it to it. That doesn't really matter for now. It's something we can always do later. So for now, this is the design I'm gonna go with. We can use the same design on both sides. We're gonna need to fill the space in here somehow. We'll see, probably with a 3D printed part that will have the mounting system for the wakeover. We'll see that later. Doesn't matter. That's something we can design later. What more? What's more important here? I quit of the idea of trying to cover the Z, because there's not a really good way to do it, since the Z plate, you see, the Z plate surpasses here, it's not like, and to go to the maximum down, we already have so little trouble. I don't see a way to get done with it. Yeah, we're gonna have to live with it. Though the best thing we can do is just like hang a piece of cloth here. That will move. It doesn't need to be that big. Something like, I don't know, or even a TPU piece, a piece of cloth, a piece of rubber, that when the spindle goes all the way up, it just needs to get to here, and then when it goes down, it goes there, and if it eats anything on the table, it will just move away because it's soft, and it will prevent most of the ships from going there. I'm not seeing us machining many stuff this high anyway. And the spindle, it's gonna be higher than this. There's no need to be like this. It's gonna be at least, I don't know, at least 3 centimeters higher. So yeah, if we just hang something here, some rubber, some silicone mat, something like that, even with double tape, it will work fine, pretty sure. There's no way we can, there's no easy way to fix this one. Yeah, I don't see any easy way to, just because the spindle plate crosses the end of the shaft, so I don't see. One way could be put a rolling system in here. So what I mean is put, let's say, let me just do an example. So if we put something like a roll in here, I'm just putting a little tube, let's say a 10 millimeter tube, doesn't really matter. This is just to make an example. It's actually not a bad idea, to be honest. Yeah, I'm gonna leave it just like that. So if we put a roll in here, of course it's going to be supported by something, doesn't really matter. And we put a piece of cloth or a plastic or whatever, even with 2 screws, in here, doesn't really matter. So the idea, if I have something going then here on this roll, and with a weight on the something soft, a nylon cloth would be ideal, with a weight, so when we go down, the thing will rub in here, yes, or we can do another roll in here, just from here to here, just to make it less. No, we can't, otherwise it would need to be there. Now it would need to rub in here. Well, but we can always do this thingy round instead of a bevel, instead of a chamfer. We can do it round. We can do it a little thicker actually. So yeah, that might be an idea. And we do it round just so the edges don't wear the cloth we use as much. And the idea would be, if it's a soft, long enough cloth that goes from here to here and there's a weight in the end, when the spindle comes down, the weight will push the cloth down and will just hang in here. And when the spindle goes up, it will pull the cloth up and go there. That might be an idea. What do you guys think? Think it can work? Something we can test, definitely. I just need to make this plate a little thicker. I wouldn't like to. Just to... so I can edge this thing round. Hey Nono! How are you? So I can do this thing round instead of chamfered, just because of the edges again, the rough edges. And the cloth would just move down with the weight. And it should work. We can try that. It's simple enough to try. Doesn't hurt anything. I can do like 3 extra holes on this plate, and we can use just double-sided tape at least to test it. Should be fine. And then we can use some cordura. Cordura, it's a very sleepy, very tough material. I actually have some of that. It's a nylon. It's a nylon cloth, basically. And yeah, it should work as a protection. We just don't want the ships on the ball screw. The linear rail, it's actually non-relevant. But the ball screw, it's kind of important. So yeah, okay. So I'm gonna move with that, with this design, and yeah, I'm gonna probably make another stream. Happy New Year, Nuno. I'm gonna ask the seller how much what would be the dimensions required for this type of bellow. And from then we will work from there. So for now, we're gonna work a little more. So I'm gonna make the aluminum parts a little more close to the final shape. So let's make it more beautiful now. Make it prettier. So we're gonna start with the skirts. Okay, so first thing the skirts need, so since we need these holes in here to fix, to actually V. So we need those holes to fit the frame. that's something we need. Hey, another CG, happy new year to you as well. So let's start with some mouse ears, because sadly end mills don't do edge corners. So we're gonna do 9, since I'm gonna machine this with a 8mm. How deep is this? Probably 20, right? Oh no, so I can actually machine this with 6mm. So a 6mm, let's do a 7 corner. So I have a 15 pocket, a 15mm pocket. The 6mm mills, the regular ones, usually are 3D. 3D means they cut 3 times the diameter, so they are 6. It means the flutes are 18. Thank you, Yoel. Um, 7. Okay, let me reference them all the same dimension, just in case if I decide to D50. See, D50, C for circle, D50, C for circle, D50, and C for circle, D50. No, D, not F. Okay, so this is what we call Mickey Mouse, mouse ears, not Mickey Mouse, sorry. So you can machine the corners. Down to that face. And we need to open these guys now. I'm gonna do 3. Should be enough, maybe 4. So this is just to clear the edges. We could do this without being so so ugly, but doesn't really matter for our it's gonna be hidden anyway. Let me just make sure the 6mm will pass in here. Yeah, okay, let me make that number bigger, like 6. Yeah, that's fine. Okay, so that's the first thing. We can round the corners in the bottom a little bit, like 3. We can do them as well on the top. Okay, one thing I want all the, yeah, we can do those as well. Well, actually these ones I want more, so I'm gonna unselect them and I'm gonna press the plus here. I'm gonna add a different dimension for these ones, like 5. It doesn't really stand out, so 10. 10 looks good. So I'm gonna do counter bores on these things, just because I don't want the, yeah, it can be 10mm. Okay, I'm gonna call it 10, but now I'm gonna, okay, D66. So D66, D66, shit, where's the D? D66. I need to delete that guy. C D66. D66. Do we need all these screws? No. Will I install them? Yes. No such thing as overbuilt. Okay. We're gonna do -6. Let me see. Well, that's why we're here. If you need any, I try to say everything I do, but sometimes I'm just working on my flow. So if you have any questions, feel free to ask. So yeah, here we're gonna have only 2 millimeters, but not even that. But yeah, tough luck. I'm not gonna mess with it because I really want the screws to be, well, I don't need them so. If we're gonna use the button heads, it doesn't need to be that much. I can do, well, at least on I don't know. Since I'm gonna need to buy screws, okay, I'm gonna do it like this. Since I'm gonna need to buy screws here, the button heads are not, well, I can order them on AliExpress. Doesn't really matter. Button heads are not easy to find here on the local stores. Well, Yoel, as I said, if you have any questions or if you want to do, hey, well, how did you do that? Can you do it slower? Please just ask. I'll do it slower. I'm just going with my flow. And if you need me to do something or to show you how to do something slower or how I did it, just ask. Don't have a problem. I'm here to help. I'm just, if no one asks anything, I'm just going with my thingy. Okay, so let's do a little chamfer just to, I usually don't model the chamfers. I only do it on the CAM software or on the CAM site when I'm doing CAM. But here I want to, since I want to check how it's gonna finish, I'm gonna actually model them, and then I can just move back the timeline when I'm doing the machining. It's fine. We can do the machining as well with the chamfers model. It's just easier. So yeah, let's do a 0.8 chamfer. Looks good. Deep chamfer. Okay, I was about to, I'm gonna do 4 instead of 6. So I could do something to make like some pockets here whatsoever, but this will only increase, it will decrease the weight, which is not ideal. It's not significant either, but mainly it will increase the machining time. But we could do something like here a pocket, something like that, like 15 from there, 15 from here, and maybe 12 from the bottom, 15 from here as well. Let's call this guy calls this guy. We need to change, it's easier as and here now we can do a pocket of something like -5 millimeters just to make it a little sleeker. And we can do the actually wait, give me a second. We can do the same thing in here, some kind of a triangle here. Instead of a triangle, I'm gonna do like this crazy shape. Same on that side. So I pressed L for line here to select two different Oh, Isan already has that stuff as well. And how is the layer addition? I usually don't have much luck with Isan layer addition. Okay, so for selecting two different stuffs, first you select one with a left click, then you shift and left click the other. I'm gonna make them horizontal. So it's just, this is just a relationship. If I change one, I'm gonna change the other. So I'm gonna put a dimension relationship to this guy. I'm gonna do 15. Oh, okay. I need to look that. Where did you buy it? Okay, so I'm gonna call this dimension here again. So, fuck, did I select the right one? This one. No, okay. So this one, same story. That way, if I change this guy, that guy will change as well. Okay, I'm gonna make this guy parallel with that one. Same story here. Shift, select, parallel. Now I'm gonna call this guy 12 millimeters from that one. Same story, D for dimension. Select these two. Oops. Oh, okay. I don't need that one because that one it's related. And if I change this one, that one will change. It will change the other one as well. So I'm gonna do the same as this here. I'm gonna make these two collinear in here. So collinear. So that means if I change this one, that will change. And if I change that one, that one, the other one will change as well. So we're gonna make it D here 10 maybe, and here we're gonna do 15. Let me check something. 24 per kilo. Okay, that's not bad, especially for glass field. Yes, glass field. Okay, so that's I was just watching. It doesn't really matter, but I want to increase that one. So let's give it, okay, like 17 maybe. And this way, that one should be equal already. So finish sketch, and let's edit and select this one as well. No, I'm not gonna drill it or like go through it all the way. No way I'm gonna do that. It's gonna weaken the part a lot, and I don't really want. But I may want it a little deeper. So select F for extrude, and let's call it 10 mil. Shift -10. So I'm not getting into anything, right? Can disable the sketch. Now let's round the corners again. End mills don't do sharp corners, so this is something. So I'm gonna use mostly an 8mm mill. It's my go-to end mill. It's 8mm. It's what I use the most. Don't ask me why, but it's probably, I should use a bigger one, but old habits die hard. Is there anything on that front plate? So I'm not sure you know what we are doing here. So we are, sorry, not that one. We are improving CNC Milo. So I'm doing CAD modifications to the original design for the, since I have some experience with CNC machines, I want to do my own take on that design. So the original design, it's this guy. Give it a second to open. So this is the original machine. This is a Milo v1.5 CNC machine. So all these parts, so these parts, these are supposed to be 3D printed, and I'm gonna make mine out of aluminum. That's why I'm working on that. Same for this piece in here. And this one, it's gonna die. I'm not gonna use, because I'm not gonna use the drag chain. Same story here on the back. So they use the bottom for the electronics compartment. I think that's the worst idea they could have. But yeah. So yeah, I'm doing my... No, okay. So no, I'm gonna, the idea is to enclosure the machine on the casa. I'm not sure if this is the most recent. I need to take a look. But the idea is to put the machine, so the machine is gonna be inside of this thingy. And to be honest, I should take a look here to see how they intend to put the machine, to mount the machine here, because I have no idea how it is. How they attach the machine or how they mount it there, I have no idea, to be honest. So yeah, the idea is to be fully enclosed, nothing in the bottom. All the electronics should come in here. So, and probably, no, this part is open. So all the electronics should be in here. The idea is to put a big panel, a big screen, or a big, more like an industrial machine panel. So with buttons for some stuff and a big touch screen to control the machine. So yeah, the idea is a little different of what they are designing. I'm pretty sure this is what, so this is nothing. Okay, this should slide to... Okay, and this it slides to the front. Yeah, I have to. I actually haven't looked with proper eyes to the enclosure, but it's something I want to do. And yeah, no electronics, so no nothing on the front. And since I intend to, okay, let's do a big chamfer here. Actually, we can do big chamfers everywhere. Okay, let's do that one first, like 3mm chamfer. Yeah, that looks good. Something like this. As I was saying, since I want to, the idea is to fill everything I can with epoxy granite. If you don't know what it is, it's a mix of epoxy with quartz sand, which makes like a plastic concrete. Very, very good for vibration dampening. It since it has epoxy, it's gonna glue very well to the frame. Since we have the slots, it's gonna fill in all the slots and all whatsoever. And we're gonna make some anchors on it as well, so it grabs even better. More to that when we actually do it. So the idea is to fill everything we can with epoxy, everything we can. I'm gonna do so basically here. So all of these inside here, it's gonna be epoxy. These corners that you see here are actually epoxy as well. So we're gonna basically join together. This is a C frame here. In here, so this C frame, this is aluminum frame. So we're gonna pretty much join it together with the epoxy, with this. So this is supposed to have a slot in here, and 2 slots as well in the bottom. So this thing will glue everything together. It's gonna be much stiffer, much more rigid, and the base will become just as one big massive block. Same story in here. So if you see, the original machine uses these 3D printed parts, which is a big mistake if you ask me. So these 3D printed parts in here to join so this is pretty much, this is a C frame, and this is 2 dual frames here, 4020s. So they use these 3D printed parts. No, silicone, you don't want silicone, because silicone is soft. It's very good dampening vibrations, but it has no rigidity. And epoxy granite, it's absolutely phenomenal. It's the best material for milling machines. The big boys like the DMG Moris, Kern, Mori Psyche, no, Mori Psyche, it's ended, it's now the DMG Mori and the Psyche. You have a ton of Okuma, you have a ton of brands, Japanese, German brands, Sweets brands that use entire castings of epoxy granite for their machines. I used myself, I made a VMC myself, and I made it also out of epoxy granite, and it's amazing. It's just amazing. It's the best material. It's kind of expensive, but it's not that much, because the epoxy is expensive, but you only use, like, I'm gonna use a fairly wet mix in here. I'm eyeballing something like 15, maybe 20% epoxy, but probably 15. I used on my machine, it was 10% epoxy, so it's basically 10% sand. Sand is super cheap, and 10% epoxy by weight. So if you use 30 kilos of mix in here, it means it's only 3 kilos of epoxy. 3 kilos of epoxy, it's not that expensive. So yes, it will give a little time, it will take a little time to mix everything and whatsoever, but in my opinion, it's gonna make a hell of a difference. So yeah, the idea is to fill everything I can with epoxy, and in here it's gonna make a ton of difference, because this is plastic again. So, and again, it's frame, so you're gonna get the slots filled with epoxy, which will pretty much get glued, and it will merge everything together pretty much. It will become, instead of two pieces, they'll become as strong as a single one. Hey Sven! Happy New Year, my friend! So yeah, that's the point of, this is why I'm doing my own version, or not my own version, it's the same version, it's just what I would change to the machine with it's the composite version of cast iron, so but it's cheaper than cast iron. It's lighter, but which is not good. But since it has such a good, the vibration dampening, it's much better than cast iron, so it doesn't need to be as heavy as cast iron to dampen the same vibrations as cast iron. So if you have the same machine that weighs half of the weight of a cast iron machine, it still is better than a cast iron machine, because the vibration dampening of the epoxy granite, it's like 3 times better than cast iron. So you're gonna be good as well, as long as you have enough weight so the machine doesn't actually move. It's amazing stuff. Okay, so the skirt, it's pretty much, I think, what do you guys think? I think it's gonna be something cool like that. Maybe I can do the central pocket a little deeper instead of 5, 8. It's gonna take pretty much the same time machining, because I'm gonna do it all at once anyway. So being 5, the only time it takes more, it's the time where it ramps down from 5 to 8. So yeah, and it's gonna make it a little lighter for selling the kits, which should be better. Let's see, so let me change the what do I want? I want physical material, that's what I want. Okay, metal, aluminum, doesn't really matter the alloy. So I'm gonna make everything 5083 cold formed, because it's the cheaper one, and it's good enough for It's good enough for, doesn't really, we don't have any advantage of doing out of 60, 82 or 70, 75. It's pretty much the same. So now I can have an idea of the weight of this thingy. So this thingy is gonna weight 1 kilo, which is not too bad. Okay, let's save it. Let's close it. And let's see how it looks in the machine. So base, body, no, skirt. Which one is it? That's why I don't like to press V, because it will hide the body and not the component, and I need to go down. Much better, huh? Much better. Okay, so these parts, this one, the X mounts and whatsoever, they are pretty much how they're gonna be. I'm not gonna use this thingy, I think. Well, it depends. I'm not sure if it will. Yeah, I think we can use it if someone wants to use the original end stop or home switch or whatever. Okay, so this thing will fit there just fine. I think I have it too big. Well, let it be. Oh, okay. Let me check the length of the motors. 95, and let me check the actual motors since we already have the actual motors. Let me check the size, if we are kinda in the same ballpark or. Where's my mouse? It's here. Okay, let's check. So we have for those that came late, I got the motors already that I'm gonna use. I'm not gonna use the stock motors. The stock motors are fine. Just not for me. Okay, 95, so we are good. Yeah, we are good. I really don't trust a stepper. Don't get me wrong, I use steppers for years on my router. It's just I don't trust steppers on a CNC machine. If it loses a step, it's a problem. So I decided to go to this cheap These cheap closed loop servos. So closed loop means they have an encoder, and it makes sure it doesn't lose steps. And this vest is awesome. So, and they are not that expensive, so I decided it would be something that I would change anyway. And I already bought the couplers, and I actually bought the 2 sizes for the original ones and these ones. So we can test the machine with the original ones, no problem. But I'm going to install those ones, definitely. Yeah, servos are the way to go. I have servos on my other two machines. On my router I have 400 watt DMM servos, which are amazing. Those things are amazing. And on my big VMC I use 1 kilowatt servos as well. And yeah, they are also awesome, and not that expensive for the things they are. But yeah, these things cost like 65 bucks, the driver and the closed loop. It's a no-brainer for me, so it's just fine. But yeah, servos are the thing. And nowadays the big problem with servos back in the day, even when I bought my machine, it was already a thing, but now it's pretty much everything as it's the auto tune. The PID tuning on the servos, it's the bitch. It is what it is. But nowadays they have you can just connect the driver to the computer after you assemble the machine. You press auto tune, it will do some movements and whatsoever to figure out the load that you have on your machine, and it will set the parameters just fine, and it's just press tune and go, and it's done. There's nothing to do. When I did my machine I had to tune it, I had to increase some values, then if that created some vibration I had to lower, and I had to increase another one. It was a fucking pain. In the end I just ended up doing a factory reset and using the machine as it was, as they sent me. But nowadays you have the newer drivers, and I know that was a thing back in the day. The problem was on my big machine, yeah. When I did my big machine, there was already those auto-tune thingies. The problem was I was using a Chinese controller, which I use and I love it, to be honest. Would I buy it again? Probably not, but now that I figured it out, I love it. Never missed anything. And it has absolute encoders. I don't have ohm switches on that machine. So basically absolute encoders, they never, well, unless they run out of batteries, but they have a recharging battery. So every time the machine is running, the machine charges the batteries. So it's pretty much, yeah, and that thing consumes like microamps. So basically what absolute servos are, it's even they are disconnected. Even if the machine is disconnected and I go down there physically moving an axis, since it has a battery, it will still read how much I moved. It will read the encoder and increase or decrease the value of the encoder. And when I turn on the machine will read the driver of the servo. The driver will read the encoder of the servo and pretty much will figure out how much I moved it, and it will be spot on. I don't have ohming on my VMC. I just turn on the machine, warm up the spindle. I have a warm up and oiling routine, so the axes move all the way and shoot a piece of oil in the ways and the ball screws, and I'm good to go. I don't need to ohm the machine every time I turn on the machine, which is awesome. And since I use those that system with the closed loop and not the closed loop, with the absolute servos, I couldn't select like the servos I want to use. I think now I probably should ask, but it would be like, hey, can I buy your controller? And I'm gonna buy the servos from the other guys that have that thingy that yours doesn't. Yeah, exactly. So yeah, pretty much that's it. There are some some servos, some controllers can use the it's kind of the same thing, but it's not the same thing. You have to do ohming, but they don't use the ohming switch to actually ohm the machine. So basically what they do is they use the ohming switch to know that you are on that specific turn of the encoder. So the encoders have they have quadrature plus index. So what does that mean? It has quadrature encoder. It knows for which direction the motor is turning, and then it has an index. The index, it's like marking the beginning of the turn, let's say it. So what they do is they use the ohm switch for ohming, and when they press the ohm switch, they're gonna go back, not until the ohm switch is untriggered, but to the index position of the encoder. So that means it only uses the ohm switch to say, okay, yeah, this is the end of the axis, so you can't go further than that, and then it will move to the actually encoder initial position, the index position, and then okay, now this is ohm. Doesn't have nothing to do with the ohm switch, so you can use a garbage ohm switch for the ohm switch, like a limit switch, just a normal limit switch, and unprecise, doesn't need to be anything fancy, because it only uses to, oh, okay, this is more or less where we are, so okay, so now that we hit the switch, now we can go find the right position of the yeah, exactly. On here I'm gonna use, since I'm using optic switches, optic sensors, I'm gonna use actually those for the ohming position. But yeah, many machines do that. They just do the mechanical switch to, okay, we are in the ballpark, it's somewhere in here. Now you're going to rotate the other way, so you can't go back from since you triggered the ohm switch. So now you're going to go the other way until you find the actual index position, and then that's ohm. So it doesn't rely on the precision of the work switch, of the ohm switch. Okay, so let's get back. Probably, but I'm not sure about that, but I'm pretty sure the most accurate ones they have actually digital scales. So basically, either usually it's magnetic, so it's basically a distance encoder instead of a rotation encoder on a motor. They actually have that because the servos need that, but they are actually guiding, so the controller doesn't get so the way mine work is it works by the rotation, the pitch of the ball screws, so it knows it relies on the pitch of the ball screws. That's the thing. So it knows the pitch of the ball screws are like 5 millimeters, mine are 5 millimeters, and it knows that the encoder has like, I have no idea, I don't remember the value of mine, but it has like 1000 pulses, so it knows that 1000 pulses, it's 5 millimeters. So mine works on the micron, and it's a servo, it's a little different, but anyway, it does the math like that. And the nice machines, the best machines, they have like, it's like a digital calipers, exactly. So it has a scale, we call it a scale, on each axis, which it's basically it's a linear encoder. It's something that has many marks, let's call it that way, and you have a sensor that is reading each mark, So the marks are precisely marked. They can be glass scales, since quartz is the most stable element there is across the with the variance of temperature. So it is the most stable component that moves the least from one temperature. It doesn't vary much with the variation of the temperature. Or a magnetic scale, pretty much, usually they are glass scales. So the feedback for the controller, it's not from the encoder of the motor. So it's like physically measuring, okay, I know the machine moved because it moved in that scale and it measured how many signals it moved, and it can actually compensate. So if the ball screw is not absolutely precise, usually they are super precise and they have the glass scales. If it was today, I would install glass scales on my system, but I didn't, so it doesn't matter. It's precise enough for me, but if it was today, I would do that on my machine. But yeah, it actually has rules, like rulers, on each axis, and it's actually measuring whatever the machine moved. And the controller then said, okay, I'm gonna say the stepper needs to move, or the servo needs to move 5 millimeters, so it needs a full, let's say 1,000 steps. And actually it detected the movement, the scale detected, oh, it didn't move 5 millimeters. Actually it moved 4.998. Oh, okay, so it needs 2 more microsteps in order to move the extra 2 to do the 5 that I told it to do. So the controllers will do that on the fly with the feedback of the scales, instead of doing the math of the encoder with the ball screw pitch. So that's how the big boys work. It's with, actually, nowadays they actually have, instead of servos and ball screws, the most advanced machines now use, actually, how do you call it, linear motors, I believe. So it's basically, it uses rails, so it's what the machine will do the strength on. But instead of having a ball screw relying on the rotation, or it's actually limited by the size. So if you want a really big ball screw, you can't actually have you can, but you need to increase the diameter and whatsoever. So now they use actually linear motors, moving the machines away, and with the digital scales they can super accurately and super fast and super strong, basically can have an infinite axis. As long as the linear rail can go, they can just put, because a linear motor, it's like coils on side of the others, and you just energize it and make the carriage move along those coils. So you just need more coils to go further away. So it's stupid, but yeah, that's how the big boys are playing now. No servos, no whatsoever, linear motors, go. No ball screw, go. Anyway, so let's go do some more work. Okay, so where we are here. Okay, so this part I think it's nice, it's good enough, right? I'll probably do a chamfer in the back, maybe not. It's gonna be more work. Well, I need to rectify it anyway. 23, yeah. Yeah, probably. It's cheaper. Well, it's not cheaper than belts, but it's a linear motor. It's way cheaper than a ball screw. and you don't need a precise ball screw. You don't need the ball screw, you don't need the motor. Basically the price of the motor will be absorbed by the ball screw. So yeah, it's a win-win, and it's better. So, and it's super. Those things are fast. Those things can make the damn carriage move fast as fuck. Okay, so let's do this one now. Okay, so this is the Y motor mount. Y motor mount. So Y motor mount. Okay, so here first we're gonna deepen this more. So 25. It's gonna be 530, at least 5 millimeters more. Edit -5, just so they're gonna be lower. These ones, so for a 3D print, I actually I have no idea how much a linear motor costs. I have no, absolutely have no idea. No point even trying to guess. But I guess it depends on, the most of the cost should be the driver. I believe, I would say, I don't know. And it needs a feedback system, of course. It needs always those digital scales that I was saying. It would be always needed, because the thing needs to know where it is, where to go. So the driver doesn't, because the motor itself doesn't have the encoder or a rotation encoder. It's gonna need a linear encoder, which is a linear scale. Okay, give me a second. Tired, let me try other. Trying to avoid paying for subscriptions, but if I don't pay subscriptions, I get ads. Yeah, usually my ads ad blocker deals with this thingy, but not today. I don't know why. Let me close it and open it again. Well, we're gonna finish soon anyway. 15 more minutes. Well, my active heater vest, it's awesome. Okay, let's see. Okay, so let's go. Probably the same thing, -7. Okay, so these ones, the top ones will screw in on the slots of the vertical beam of the column, but these ones gonna screw in on the top of the bottom beam. So yeah, they can be deeper. They can be, so they have 20. If we use 30 millimeters or even 25, they can be 15, then they can be 10 more millimeters. 17, yeah, minus 17 should be fine. And they should, yeah, we have 10 millimeters meat, and we are good. These ones are bigger than that one, those ones. Okay, let's put those ones at 10 as well. Edit. Are they? No, they are not. This is why I always like to reference the measurements to the same one, so I can change one and they all change. The problem is not when you are designing the part. The problem is when you're changing the part or tweaking the part. So I'm going to do a big chamfer on here, something like 2 or 3 millimeters. 3 looks good. Well, okay, it needs to have some kind of sensor. So it's basically it's going to be a scale on it anyway. So, but for specifically milling machines, I'm pretty sure they're gonna use the same measuring device that they're gonna need to use for the controller. So it's like a win-win. Instead, like on a regular ball screw machine, you're gonna have a servo which has an encoder, and then you're gonna have a ruler for the controller physically know where the machine is, instead of guessing according to the steps and the pitch of the ball screw, whatever. So there's no point of having two sensors doing the exact same thing. So with a linear motor, if you're gonna have a sensor knowing the physical position of the carriage, there's no point of having a second sensor doing the exact same thing. So it's one less thing you need to worry about, and so it's gonna make it cheaper. Okay, so 0.8 on these. I'm gonna use on these as well. And these as well. Yeah, fuck it. These, let's do it all. Well, actually here probably... Shit, I shouldn't have. Because I'm probably... Well, fuck it, doesn't really matter. Can be. Here, 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 and yeah, here too, why not? Well, this one won't be as big for sure. This one and this one are gonna be something like just 0.3 to break the edge. Here there's no need for, I probably will do just for... Hey Beanie! Just for breaking the edges as well. Boa noite, my friend. Bom ano. Happy New Year, Beanie. Okay, let me close the Casa because there's no point. I'm gonna close the Milo. Well, not yet. Maybe someone has some kind of question about it. Okay, so let's see how it ends up. Looks good, looks fancy. Oh, I forgot to change the... Let me change the material. Oh, is it your birthday today? Happy birthday, my friend. Well, I almost missed it, if it is today. Thanks, my friend. Okay, so I need change the material of the body. Okay, all of them. Physical material. Let's go aluminum. Aluminum. Save. It's gonna be more beautiful like that. Let's do the same to the... Okay, let's start from the beginning and do the same at all. Just it's more visual that way. Spindle mount. Okay, we need to do some... Pimp my spindle mount. Well, the spindle mount, well, it's pretty much only gonna change the okay, let's put I want a little more meat on this thingy. +6. 45. Yeah. For starters, I'm gonna start with the original spindle mount, or the original spindle, which is a 1.5 kilowatt high frequency spindle. Is it ideal? No. Will it work? Yeah, it will. Later in the game, yeah, I want to do something more fancy. Something like maybe a custom-made spindle, maybe some bt30, I see some cool stuff on AliExpress, which will allow quick change, and we could do automatic change as well, but I don't see automatic change on a Milo, which would be overkill. We never know, maybe, but quick change would be nice to have the tools and just quickly change them. So ISO 20 would be the ideal size for this machine, but I haven't found anything with those tool heads. But I found some cool stuff with BT30, and BT30 it's quite generous tool. So I'm thinking later of going with something like a 2 kilowatt spindle servo and BT30 spindle. Maybe, we'll see. First I'm already spending too much time with this machine that I shouldn't, because I don't really need this machine. I'm only doing this machine for you guys. Because people ask me, hey, what do you think about servos, about Milo, since you work with CNC machines and whatsoever. Because I have, even my router, it's better than this machine, so I really don't need it. But yeah, I love you guys, and I'm doing this just for you guys, so I hope you really enjoy it. But who knows, we'll see. It's an upgrade that... Yeah, you have some blame. You are a really bad influence. But yeah, what the hell, I love this stuff, so who cares? I'm just messing because I really like this stuff anyway, so. And to be honest, I'm actually a little stubborn because the first time I saw someone assembling this machine, and actually it was Steve building this machine, and I pointed some stuff, the guy that designed it was there, and I pointed some stuff to the guy, and at the time he called me crazy and whatever, and now he's doing upgrades on the machine based on the stuff that I said it was wrong. So, and even though they are making adjustments and tweaking or a new revision, and even so they are making bad choices. But yeah, so I'm also doing this a little with yeah, that's true. That's true. I'm a little kind of crazy, but not in that way. I'm crazy, but I'm not that dumb. And some stuff he did here, it was dumb. It was dumb. Let's call it the way it is. Shit, I forgot again the... Okay. So since we are building, basically the idea is, since we are building this machine, let's build it the best we can. We don't need mass on the, we need mass on the column, on the spindle itself, on the spindle mounts. Yeah, ideally what we could do, and it would be actually a good idea, it's to add a third clamp. That would be good, but it's gonna be a pain to align it, trim it, and make absolutely sure it is the same size. Otherwise, if we have the spindle, if the point is with two, well, let me... Yeah, exactly. So the point, we could add a third one. So let me open here. We could add a third clamp. We have the space for it, kinda. Well, we don't. Okay. But it would be bad. It would be bad. But we can make it wider. But then we only have two M5 screws holding, so there's no point. I'm not even going away with that. So on here we could actually, on the bottom one, no, we can't. Nah, no point. We're good. Yeah, I'm gonna leave it like this for now. There's no point. Then we can actually put something here, but I really like, to be honest, I really like this cover. It makes it like look beefy, but I really like the cover. So the idea for me, it's kind of reshape this later and actually make a cover to cover the spindle mount. I think, because I really like, to be honest, I like the way the guy designed it. So I would really like to keep it like that. I like the way it looks, so probably I'll do some kind of, I don't know, redesign the cover just to cover the spindle, because I really like it. Instead of being naked like this, I think it's cool the way it original looks. Okay, so now what next? Well, it's time for me to turn off. So this one is ready. I'm gonna just change the colors of the materials to okay. Yeah, I heard there was some kind of a mod for that, which is good. So if I can just change the mod for my clamps, and the clamps may change yet because yeah, these just need some chamfers here, 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 there, here on top, here, 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 and here. 0.8, 0.5, something like that. 0.8. I need to check the other ones, and I need to add one here and one here. Here, 0.3. Fuck, I forgot that one. Yeah, we're good. We're gonna save it. Gonna close it. Here everything is good. Just need to change the physical material to aluminum. Spindle mount. Okay. Fine. Okay, I think we only need to work the front piece in here, so it's gonna be fast anyway. Okay, so again, I'm gonna 10 millimeters, 10 millimeters, 10 millimeters. So I'm gonna do 4 since this is a low. We might need to do some changes on these after I have some more information on the wakeovers. Let's do 5 here, or no, that's too much. 3, yeah, looks good. Yeah, that's fine, everything looks good. Do some chamfer here, can't do much. Can do 2, right? No, 2 it's too much. 1.5. Slowed. So when I have more information on on the way covers, then we might need to adjust this guy. We'll see. Okay. Okay, looks good. Oh, now that I'm syncing, but it's gonna waste space. Well, kinda won't. Well, we'll see. Okay, so it's not showing because I hit it, right? It's here. Nope, not this guy. Oh shit. What dish? Here. Okay. Same story for this guy. Well, I was thinking I do a anodization myself, and I was thinking of anodizing it, but it's gonna be kind of expensive. In here in Portugal, sadly, there are no anodization companies, which sucks. So I was thinking of doing it, but I'm pretty sure I'm gonna leave it just plain aluminum. I will need to see, because just the powder alone, it's not that many. But I don't know. I need to really think about it. It's so much work. And I don't know how much some company would charge for anodizing these. To be honest, I have no idea about the price of, like, I'm pretty sure it's by square something, like square meter. It's about the surface. It's probably a price for the process plus something by the surface. I'm not sure. What I'm doing. I need to do physical material. I have no idea how much it would cost. And I know in Spain there are some companies that do it, but shipping it to there, then they shipping to me, plus the price of the anodization, I don't think so. I would prefer to do it myself, because I could do it pretty much everything in one batch. I have the means to it, but I would need to figure a price, but should be something like at least in a range of the 80 euros, something like that. So 80 at least, I would say. I would pay, if I had the company that did all the parts for me for that price, I would pay it. I would pay 80 euros instead of doing myself. Because anodization is a fucking pain to do. I don't know if you guys are familiar with the process, but it's a fucking pain, at least to do it well. Hey, where are my edges? They're probably... Yeah, so that's pretty much everything. So the only, okay, there's this one missing, but this one is pretty much done. Let me, this one I need to sync because of the mechanism I was thinking of doing. Where is it? So this is the Z. Oh, we have also that guy there. Okay. So the Z F10 mount. Yeah, powder coat would be too thick. Cerakote, it's not ideal. The ideal thing here would be anodization. That would be the ideal. Let me remove this thingy because first I need to do some fillets. Hey Diogo, Happy New Year, welcome. Fuck. Okay, probably I need to remove this guy and this guy. Exactly. And here I would do something like nope, no tangent, and 2 millimeters. 2 and okay, and that one gone as well. Fuck me. Yeah, like that. Could work. We'll see. Okay. Let's give it a aluminum look. Just to stand out. No idea, Duke. No idea if those things. What is your problem exactly when I'm trying to do stuff but having some issue trying to get like USB and SD card stuff where I need them? You mean like holes for the USB thingies, or I'm not sure what you mean, questionable. Okay, let's figure out this guy. Oh, this guy is pretty much how I want it. Okay, so we have a problem here, or more a problem here. Just need this guy to be longer. And yeah, let's do some chamfers in here. Okay, first some fillets here, here, something like 10s. Looks fine. Let me check the size of this thing. 26 is a lot. 26 is a lot, especially for a 3mm. Okay, so I'm not sure about what's your problem, but or what's your part. Let's start something here. So okay, let's make just a regular box. Edit sketch. Let me do some dimensions I haven't done. So let's call it 120 and I don't know, 80. I don't care. Fuck. 80, not 800. Okay, so let's say this is your box. I'm not sure if I'm gonna make something really stupid, but so if you're designing a hole in here, I'm not sure about what your problem, so you can just do the shape of the hole and then you can call D for dimension or go to on this button and just put, okay, I want it to start at 9mm from this edge and I want the hole to go to 80mm from this edge, and then I want it to start in 15 from here, and I need the hole to be 50 from here. Not sure if this helps you. And if you have, let's say if you have rounded corners, and you want to do the same thing, so now you lost the reference, you can do P for project and you can project that line and that line. So now you have a reference from this wall in here, which is this line, and from this wall in here, which is this line. And now you can do the same thing. If you want it from this here to here, 9, and this here to here, whatever you want, 78. Fuck. 78. Okay, glad I could help. Okay, I need to do, so this one, this is what? 26, so this needs to be way... That's why I'm here, my friend, to help you. Let's do quite a big chamfer here. And let's do something I don't do usually, but sounds like fun. 0.5 chamfer or 0.8 chamfer. And here, and here. Looks good, looks beautiful. Hey Spectra, Happy New Year! Shit, and I just remembered I'm owing you some corner brackets. I need to make them. Fuck. I completely forgot. Let's be honest. Okay. Let's do some stuff in here. Oh wait, I'm fucking up. Shit. Yeah, I'm fucking up. This chamfer. This needs to be barely here. If I don't even need it here. Delete. Yeah, that's fine. Thanks, my friend. You guys are awesome. It's not a big community, but damn, you guys are awesome. Well, I take awesome over big any time of the week, especially twice on Sunday. So... what's this? I don't remember what's this. But it's here, so I'm assuming it's for something. Oh, okay. It's here, but it's not complete. It needs to go all the way there. That one missing. And I'm fucking up on this one and this one, because I want those big ones, like 2 millimeters, big ones. Yeah, like that. That's what I want, something like this. Well, no way. You are almost done with your micron? Jesus, 1000 millimeters per second. That thing will take off like a fucking rocket. Jesus. Okay, and that should be... fuck. That should be it for now. Yeah, stay out of his way. It's gonna fucking... it's going... when you start a print, 1 hour later it's in the moon. Oh, did I change the material? I don't think so. Don't remember. No, I didn't. Fuck. Okay. Okay, so looks good, right? We have some issues there, but that's not a problem. So tomorrow I'm gonna place the order for the aluminum I need. You guys are crazy. $1,000 on the fucking micron. 60k acceleration. Jesus. That thing doesn't move, it teleports. Okay, so yeah, I think we are done with the CAD. I'm just gonna need to. I'm gonna get information on the quantum printer, exactly, on the wakeovers. And when I have some information about that, we gonna adjust the rest of the design. It's just whatever. It's just that's missing. So it's gonna be something. It's gonna be easy stuff anyway. Some printed parts maybe should be fine. Yeah, I'm gonna order the aluminum for this stuff so I can start having some idea of the price it's gonna cost. But it shouldn't be the end of the world. And of course, the skirts are not absolutely needed. Can be an optional part. Maybe, probably, I'm not even make part of a kit or make like optional. The rest, I'm pretty sure, yeah, the rest I recommend everything. The rest it's pretty much. The spindle brackets are also kind of optional. So yeah, probably I'm gonna do that as optionals because they are not absolutely needed, but recommended, but not needed. Well, one interesting thing. The parts, yes, so these parts, the absolutely needed are the ones for the ball screws, which are the parts that hold the motors, and the counterpart where the floating side is. Well, to be honest, the floating side can be also 3D printed, because this thing, as I said many times, it's not gonna make any forces, it's just so the ball screw doesn't wobble. So actually, if we are gonna be absolutely conservative, the end parts, but it kind of adds rigidity to the whole thing. But they are not absolutely needed. Yeah, the motor mount definitely can be 3D printed if you're crazy enough. So the Z1, well, nah. If we're gonna be honest, the critical parts needed for the ball screws are actually the motor mounts and the ball screw mounts. the ball nut mount, sorry. So these little guys. But I'm gonna do the kit as with a complete. So I'm gonna do a complete kit, maybe. Depends on the interest. Or maybe I'm gonna do a fundamental kit, which is the both sides of the axis plus the ball nut mounts and some specific hardware like the bell wheel washers for preload in case of you using double nuts. If you use single nuts, there's no need for it. And then the optional parts available as well, like the skirts. I think the spindle brackets will be part of the fundamental, because let's be honest, it's kind of fundamental to have the clamps. You want the spindle as rigid as possible. If you are spending money to put the damn ball screws, I'm pretty sure you want the damn spindle mounts as well. And the skirts I may need to change because I'm pretty sure I want to bolt the machine to the damn frame or the box, the enclosure. Let me check something really quick. $320. We'll see. Okay, anyway, we are done for today. I'm gonna send right now after the stream. I'm gonna send the design of the bellows to the manufacturer. And according, I'll need to know the full retracted length in order for us to know if we need to change anything more or tweak anything. So yeah, that's gonna be all for now. I'm gonna close this thingy. I'm gonna close this thingy as well. I'm not gonna save. Close this. Okay guys, that's it for today. I hope you guys learned something. It's supposed to be the last stream, but we're gonna do a very last stream after I have the final dimensions of the bellows to see if we need to adjust anything according to whatever the seller gonna say to us. That's it for today. Again, Happy New Year to everyone. This is the first stream of this year, so I hope you guys enjoyed it. I really enjoy your company. Thank you for making me company. Thank you for collaborating with me and interacting with me. We'll be talking again soon. Yeah, that's it. Thank you for keeping up with me and my stuff, my crazy shit. So, see you guys next time. Good night. Enjoy, everyone. Take care. And have fun, of course.